In this video, we are going to do a recap of what you already watched from the Unit 3 video on complex numbers. This is a brand new topic that is new to you. So I'd like you just to watch me go through this first problem, and then we're going to talk about why we use the TI as a tool to answer these. So what are we actually doing here? In this problem, again, you are just watching this, I want to find a way to simplify this. So I want to find a way to really condense this by adding like terms. So I'm going to go, what is negative 3 plus 7? So negative 3 plus 7, you are only watching me. Then I'm going to do, what's positive 6 plus negative 8? Notice they both have i's. Negative 3 plus 7 is 4. 6 and negative 8 is negative 2, and this is an I. This is considered to be standard form. Standard form of a complex number has a real portion and an imaginary portion. Let's do it on the calculator together. So grab a calculator. My suggestion would be to always do adding and subtracting and multiplying by simply picking up a calculator and showing no work. Okay, start with the parentheses. This is a negative sign. So go below the 3 and hit a negative sign. Go below the 3 and hit a negative. Not a subtraction, a negative. Then it's going to be 3 plus 6. Now where do we get the I? Hit the blue second key and go all the way down below the 2 to the decimal. And end parenthesis. In this problem, we're going to do addition. Start the second parenthesis. 7 subtract 8, not negative. 7 subtract 8. Again, we need to insert an I, so we're going to hit the blue key. Go below the 2 to the decimal and end parentheses, and we can see the exact same answer. Your calculator will always provide you the answer, and it should be in standard form. So it's going to be the real portion followed by the imaginary portion. Stop, turn to your partner while I write down the next problem and make sure you're both able to achieve the same answer on your calculator. Go ahead. Talk to your partner, make sure you both have it. Okay, so in this problem, this is the second example. I'm going to illustrate really what are we doing here. So in this problem, again, we're just combining like terms. So I'm starting with what's real, what does not have an I. So 9 subtract 11. 9 subtract 11. Okay? The next is going to be the i's. Negative 8 subtract negative 12 with the I in back. Negative 8 subtract a negative 12. They both have i's in back. 9 minus 11 is a negative 2. 2 negatives make a positive, and negative 8 plus 12 is positive 4. Attach the I. Again, we're going to do it on the calculator, but I want to illustrate really what is happening within the calculator. Okay, let's do it together. So parenthesis, 9 subtract 8i, and parenthesis. This is not a negative. This is a subtraction. Parenthesis, 11 subtract 12i. And let's see, do we get the same answer? We sure do. Same answer. So the question is, if you're asked to simplify, you can simply plug in the calculator, and this is your answer. Asked to simplify, plug it in, answer, okay? Now if it says within the answer what's the real portion, it's the one without the I. What's the imaginary? It's the one with the I. That is adding and subtracting. Now we're going to build upon what you learned in 8th grade. So here's the third example. So instead of adding or subtracting, like the two previous problems, now I've pushed the two parentheses together to do multiplication. So multiplication is going to be using the FOIL concept. Again, you're just watching, you're not writing this down, just watching. So I'm going to FOIL, I'm going to do it quickly assuming you know what foiling stands for. Multiplying the fronts to end up with 40. Multiplying the outsides to end up with a positive 15, attach the I. I'm multiplying the insides to end up with a negative 16, attach the I. And multiplying the last, negative 2 times 3 is negative 6. Now here's the kicker. There's 2 i's. 2 i's is I squared. Now in that video, what does I squared equivalent to? Anybody? So I'm going to replace this. Now watch this. I'm going to be lazy. That's kind of who I am. Watch this. So I'm going to go, okay, I had this as an I squared. Now I make it a negative 1. Okay, so let's go ahead and we're going to combine. I have 4 different groups here, 4 terms, and I'm going to combine them. So here's a positive 40. Now, negative 6 times negative 1. Negative 6 times negative 1 is a positive 6. And then I have these i's, positive 15i and negative 16i. I end up with 46, positive 15, and negative 16 is negative 1i. Did I get the right answer? I don't know. Let's check. Clear your screen. Parentheses. 5, again, this is not a negative. This is subtract. 5, subtract 2i, end parenthesis. Beginning parenthesis, 8 plus 3i, end parenthesis. Okay, turning to your partner. Give me 1 second, Anthony. Turning to your partner. What represents the real portion of this final answer? To your partner, go. Now, this is tricky. What represents the imaginary portion? If you just say I, it's wrong. It is negative I, or negative 1i. Anthony, do you have a question?
I was going to say, are you able to just put the I if it's 1, or do you have to put 1 I?
Nope, it's the same as like an X. So you could just put negative I is fine. So for everything I've gone over, when you do the self-assessment of learning or the homework, when you have adding, subtracting, or multiplication, I just did this so you understand the concept. You're able to plug it in, get an answer, plug it in, get an answer, plug it in, get an answer. Can I have a red cup or a green cup based on your understanding before we hit some of the hard stuff? Okay, thank you. Sorry for sitting down. I just want to make sure I can tape this for anybody who needs to rewatch it. Okay, we're going to move on now. Now, this is definitely what I want you to write down with me. So here's the first one. Just like the 3 previous problems, our goal is to simplify the expression we're given. This says 2 subtract 7i divided by 4 plus 3i. And in the video, I went over how do we simplify fractions that contain i's. We are not supposed to provide a final answer that has an I in the bottom. So to do that, what we're going to do is we're going to multiply the top and bottom by the exact same thing. Now I just want to go back here. Not sure if this was in the video. I just want to give you an example of how this works. If I said 1/2 and I said, Bree, give me any number, go. 3. If I multiply the top and bottom by the exact same thing, I get 3/6. So what does 3/6 reduce to? So as long as you multiply the top and the bottom by the exact same thing, you never change the value of your original fraction. Okay? So that's what we're doing here. We're going to multiply this by the same thing. This is called multiplying by the conjugate of the denominator. So I'm going to take whatever the denominator is, I'm going to write it down, but I'm not going to put a symbol in between. The denominator in this case was 4 plus 3i. So I write 4 plus 3i on top and bottom. And just like we did over here with Bree's example, she said 3. Remember, it doesn't change anything. As long as these are the exact same expressions, it will not change the original fraction. Now, conjugate means opposite. So whatever symbol here was in the middle, we do the opposite of. Please add parentheses to the numerator and denominator of the original. Now, here's where you're going to work with your partner. In 3 seconds, I want you to decide who's taller, you and your partner, and I want that person to raise their hand. Go. Taller person raising the hand. Okay. Taller person, you're going to use your calculator and you're going to multiply these two and write it down. Shorter person, you're going to multiply these two and write it down. You have 20 seconds to do that. Go. Look what your partner has down and see. Do not circle this. I'm just circling it so it stands out for you. Do not circle it. Give me a cup side by side if you and your partner were able to achieve this together. You have the same numerator and the same denominator. Cup side by side if that's the case so I can see where we stand. Okay, so we're not done yet. But this is showing work. Watch. You're given this. You show the concept of what you know you need to multiply by. We get to this now. We got to keep going. So this has to be a good share. It has to be shared with both the top and bottom. Negative 13 over 25. You're doing the same that I am. Subtract 34 over 25 with an I attached in back. When we give a final answer, it needs to be in standard form and it needs to be fully reduced. Some of you are really good with your multiplication skills and you can naturally do this in your head. Others are not as good, so please follow along. Here's where you can check, did you fully reduce it? Forget about the i's. We're going to plug in the first one. Please practice with me. Type in negative 13 divided by 25. And now on the left-hand side, you're going to find a math key. Hit it one time. On the bottom, you're going to find enter. Hit it twice. This tells me that this is in fully reduced form. It cannot be reduced any further. Let's do the next one. Don't attach the I to it. Negative 34 divided by 25. Again, some of you can do this in your head. Others will want to use a calculator as a tool. Hit math once. Press enter, bottom right-hand corner, twice. If it's the same number, it means it cannot be reduced. This is my final answer. So these two are equivalent, but this is in proper form. This is the real portion. This is the the imaginary portion of the complex number. Okay, we're moving on to the next problem. We're going to build upon. Oh, I got a backside. Good. Here we go. Here we go. Ready? So here's your next one. 3 plus 2i over 4i. Please write it down. Complex numbers contain a real and an imaginary portion. So does the numerator have a real and an imaginary portion? Does the denominator have a real and an imaginary? It's missing this real portion, right? The one that doesn't have an I. So here's my question. When I say, what can I put in front? Like, what can I add to the bottom that doesn't change it? Think about your current age. What number can you add to your age and it doesn't change your age? 0. So this is the problem we're working with, and we want to rewrite it or simplify it in proper form. So I'm going to multiply. Let's put parentheses. And now I take whatever the denominator is, and I'm going to rewrite it, but I'm not going to put a symbol, a plus or minus sign, in between yet. And now I go back to the denominator. This is called a conjugate of the denominator. I go, okay, it was addition, and now needs to be subtraction. Okay, you're practicing on your own, and you're kind of practicing for speed. I'm going to give you, let's go 45 seconds to multiply the numerator and the denominator. It does not have to be reduced yet. Go ahead. Only look up when you're done. Can you give me a green cup if you were able to achieve at least this part? A green cup so I can see where we are. If your partner has a red cup, please help them out. If your partner has a red cup, please help them out. So what do we do next? This needs to be shared with both. So I'm going to rewrite this. 8 over 16 minus 12 over 16. In no way am I telling you to stop doing mental math. So if you can do the mental math, then do that. It's much quicker. If you struggle with that mental math aspect, then what we're going to do is we're going to go 8 divided by 16. I'm using the calculator to reduce this quickly for me. I hit math on the left-hand side, and I press enter twice. This reduces to 1/2. Hopefully, most of you can do that on your own. 12 divided by 16, same thing. Don't add the I forgot the negative sign. Negative 12 divided by 16. Again, I hit math, enter, enter, negative 3/4 I. This is my final answer. This is equivalent to this original expression. Between you and your partner, the person on the left-hand side, what's the real portion? 1/2. Person on the left side, be careful. What's the imaginary portion? If you say 3/4, you're wrong. What is it? Negative 3/4. Negative 3/4 with the I. Okay, let's have you try one. But I want to get you off on the right foot. Please write this down. This is the last one with division. So before you start, you need to ask yourself, before you start, does this problem in the numerator have both a real and an imaginary portion? What's it missing? The real, so let's put a 0 plus in front. Okay, we're going to take this like an actual quiz problem. You have 90 seconds to do the best you can, and then I'll go over it. Begin. Please put your cup side by side when you are fully done. It's fully reduced. Since most of you are at this point, I want you to let you know, when you do this, you have to show your work. So what is showing your work? You're provided with this. You multiply it. The conjugate you're multiplying by. You get to this point, but you can't stop. Remember, you have to keep going. That's 5 has to be shared with both. So 5 over 5 plus 10 over 5. If you need to use a calculator, do so, but hopefully you can get 1 plus 2i. Okay, put a red cup on top. Red cup singular on top if you understand how to get to this point. Now, yes, you could put this into your calculator to reduce if that's your comfort level. Okay, so before I move on to the next ones, we need to review the number I. So this was all in the video, but it is brand new. Remember, we've learned that I squared is the same as negative 1. I would write this down, kind of just helps with memory. So I to the third is like, okay, first there's 2 i's, right? And then there's a third. Now, why am I separating like that? Because the 2 i's are the same as negative 1. So this is negative 1, and then an I, negative 1i. And then 4 i's would be, well, I can split them up into groups of 2. 2 i's make negative 1, so this is like negative 1 times negative 1, which is positive 1. And 5 i's would be 4 i's and then an additional 1i. That makes up 5. Now, why did I do that? Because I know 4 i's is the same as positive 1. And then taking it times I is positive 1i. Okay, all part of the video. Okay, so here we go. We're going to start counting on our fingers. So we're going to start with I to the 7th. Okay, so you're looking up at my screen. So how do we do this? Okay, put 5 fingers out, please. 5 fingers out. After we put our thumb down for 1, we never bring our thumb back up. So I just want to count first of all, and I want to show you the common mistake. So I'm just going to count to 9, just random number. So if I count to 9, it's 1. Now watch closely. 2, 3, 4, 5. Now when I go to 6, I don't bring this back up. 6, 7, 8, 9. Did everybody see that? Okay, and everything we do is going to follow this pattern. This is the first number, the second number in the list, the third number, and the fourth number. There's 1, 2, 3, and 4. Okay, here we go. We're going to go I to the 7th, okay? So here we go, counting with me. There's 1. Do this with me, please. Here we go. 1, 2, 3, 4, 5. Keep the thumb down. 6, 7. It's the second number in the list. What's the second number in the list? Done. Okay, let's try I to the 16th. I'm just doing random numbers, okay? Random numbers. Here we go. Ready? Put down the thumb for 1. We got to count it still, but we never comes back up. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. It's the third number in the list. What's the third number? Positive 1. Okay, with your partner, go through this slowly. Slow it down. And I want you to do I to the 20th with your partner slowly counting. There's a lot of confusion sometimes with counting in the past. Go. Pop the thumb down and don't bring it back up. Go with your partner, please. Yes. Give me a green cup if you feel confident. I won't call anybody. Give me a green cup if you feel confident. Leave a red cup up if you're feeling confused. Green cup, I'm feeling pretty confident. I'm not going to call on you. Red cup if I'm feeling confused. Okay, here we go. You ready? I'm going to do 20. Please watch. 1, it goes down, it stays down. Again, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. How many of you got the third number? Third number is a positive 1. Okay, let's do this as a practice quiz. It obviously is not a quiz, but let's do it as a practice quiz. I want you to do I to the 10th by yourself, and I'm going to time you. You have 25 seconds, go. Tell your partner your answer. Go. What do you think it is? 10. Here's the deal. You have to count this, but then you don't use it again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. How many of you had the first one? First one. What is the first one? Negative 1. Okay, we're building upon this. Here we go. I'm flipping this around. Okay, flipping this around here. So now, and everything, remember, goes back to this. So I will probably flip it back around, but actually, let me see if I can do this, if this will help us. It won't be quite as confusing. Okay, let's do this one. I want you to write this down. Negative 2i times 5i times negative 3i. Well, how do we go about doing this? So you ready? I just taught you how this works because I feel like if I didn't teach you this, it wouldn't make sense, but I want to show you. I'm going to show you the slow way and the fast way. You ready? Here's the fast way, or here's the slow way, but I don't think it's that slow. Okay, negative 2 times 5 is negative 10, right? Negative 10 times negative 3 is positive 3. Okay, this is the slow way. How many i's do I have? Okay, I come up here. What's 3 i's the same as? Okay, what's 30 times negative 1? That's my final answer. That's a slow way, okay? Do this with me. Here's the fast way. You ready? Do this with me. Parentheses. Do it with me. Negative 2i. Next parenthesis. Positive 5i. Next parenthesis. Negative 3i. Done. What'd you say? I think it is 2, but I'm just showing people alternatives. Let's go back to this. What if I said to you, I to the 20th? Do it with me right now. Now, this is different. Pay close attention. Are you ready? I want you to do second and the decimal. So we have just an I. I'm going to show you how to evaluate this on the calculator. So we have an I. Now hit this little caret key right here. It's right above division. And type in 20, and there's your answer. Let's do this one. Let's do I to the 7. So hit I again. Do the caret key, which is above the division sign. Do a 7. There's your answer. Negative 1i or negative I. So you're like, Miss Bradley, why did you teach us all this counting when I can just do it on the calculator? Because I want you to understand the concept versus just being able to plug something on a calculator. You can use either method. Okay, here's the next one. Let's try to stump you. I want to see if you can get this one right without a calculator. Are you ready? My guess is only about 2 of you will get this right. Let's have you even work with your partner. This is the problem. You have 40 seconds. Let's see what you can get. I'll walk around the room and see if you get it right. Go. That is 7i in the first parenthesis and negative 2i squared in the second. Hands up when you have an answer. Don't use a calculator. See if you can use it without a calculator. Okay, final answer. Thank you for trying. No, thank you for trying. You can't use a calculator.
I'm not using
Oh, we got a cheater over here. Addie's a cheater.
I'm not touching number one.
Woo! We got one person with the right answer. Give you another 10 seconds. Challenging you here. When I show you, you're going to be like, oh, that was easy. Look at Anthony, a little cheater on the calculator.
You already told me I'm wrong.
Because you only had a problem down. Woo! With the calculator, good job. Okay, I'll give you 10 seconds more. We go like this. Come back up there. No, good try. Yes! Without a calculator? Okay, so let's go over this. This is so much simpler than you think. Hey, yes. Nice job. Okay, so much simpler than you think. Okay, so here's the concept that students get confused with. Please look up here. This is called the base. This is the exponents. How many times do you want to write the base according to this? 2. Okay, ready? What's 2 negatives make, by the way? So I don't want to be confused with that. So 7 times 4 is 28. How many i's do I have? What's 3i equivalent to? Negative 1i. Negative 28i. Done. Okay. We're on to our last concept of this. Last concept. Give me 1 second to pull this up. And this is going to build upon what you learn in 8th and 9th grade. So we have 4 problems to go through. This is a square root. It's a type of radical. I wish I could kind of reform math and have, when you are first introduced to square roots, I wish you knew this. How many of you know that there's a hidden 2 right here? Raise your hands high. Nice. There's a hidden 2 here. So it's a type of radical. We're going to learn in the next couple of months about there's like 3s, there can be 3s, there's and 4s and 5s. But whenever you think square root, there's a hidden 2. Now we know you can't take the square root of a negative, so that pops up front and becomes an I. And then ask yourself, what's the square root of 144? 12. Proper is to put the I behind it. So is I 12 wrong? No, it's just not real proper. 12i is best. So that's the first thing. And now we're going to go ahead and talk about, again, what you may or may not remember from 8th and 9th grade. So the first thing is when you have the same type of radical, these are both square roots. They have hidden 2's there. Any number other than a 2, you'll know. They actually put the number, okay? So when you have the exact same type of radical and you're multiplying, you get to actually combine them. So negative 5 times negative 4 is actually a positive 20 because 2 negatives make a positive. So is this a final answer? No. We're working with square roots. So I'm thinking about those perfect squares. 1, 4, 9, 16, 25, and so on. What is the largest number here that divides into 20 nicely? Well, 16 doesn't, there's 16 times something can't give you 20 without it being a decimal or fraction. 4 times what? Okay, so 4 times 5. I'm breaking this down. Square root of 4 is 2. Square root of 5 is ugly. Problem is done. Next up, 2 square roots of negative 12. You're writing this down. We have 2 left. Now we cannot take the square root of a negative so that negative jumps out front and becomes an I. It jumps out front and becomes an I. And then we ask ourselves, okay, square root of 12. What is the largest perfect square that goes in nicely, divides into 12? 4 times 3. What is the square root of 4? 2. Okay, so now I'm just going to combine like terms. 2 times 2 is 4, and I have 4I radical 3. Sometimes students say, like, does the I have to go like before the radical or after? The reason why we generally say put it before the radical is when it's after the radical, like if I just put it here, it's hard to know, do you mean for it to go underneath or in back? That's why we tell them, normally put it before the radical. Okay, last problem. Let's see what you can do here with your partner. I'm going to give you 40 seconds. I want you to reduce this as far as possible. This is the expression. Begin. No, I've never used a Casio, so I don't.
Okay. Because I have a Casio that I checked out.
Oh, yes. No, we don't actually use Casio the rest of the way going up.
Okay.
So that's the calculator you want to get used to.
Okay. I think
Yep.
Vancewoy has the TI 80.
Yes.
Is it the
Same thing.
It's in the same place?
Mm-hmm. Yep. So the first step is sneaking out that I so we can do the work. Then you ask yourself, what's the largest? It has to be the largest to fully simplify. What's the largest perfect square that divides nicely into 32?
16.
Now 4 works, but it's not the largest. It has to be 16. 16 times what?
2.
Otherwise, it will not be fully reduced. The square root of 16 is 4. And negative 3 times 4 is a negative 12. This is the simplified form of this expression.